Hello all, welcome to our YouTube channel Gyan Academy. As you know that we have recently made this channel and we started by uploading our first video which was on biology. Today we will be discussing the physics part and I will be discussing the physics for plus 2 class, and for discussing this I will be following NCERT book and I will try to discuss each concept from NCERT line by line. So today we will be starting with the chapter 1, which is the electric charges in the field. I will be starting our approach in this. It will be like this. We will be starting with the basic concepts and then we will try to solve the problems, the numerical problems, both which comes in board exams and which also comes in the competitive exams. तो हम आज फिजिक्स वाला वीडियो स्टार्ट करेंगे. तो पहले हम अपने बेसिक कॉन्सेप्ट्स स्टार्ट करेंगे, देन वी विल डिस्कस द प्रॉब्लम्स, और प्रॉब्लम्स हम वो डिस्कस करेंगे विच आर इम्पोर्टेंट फ्रॉम ब्रॉड पॉइंट ऑफ व्यू, एंड देन gradually we will move to the problems which are important from competitive point of view. So we will first be discussing about electric charge in the field. So today we are going to discuss that. So now if I will show you one video and you will agree with me that this is something which you all might have seen happening. So these are the comb. It is in first video it was attracting paper, the piece of paper, and in second video it is attracting a water stream. So one thing is common in these two videos, and that is the comb, it is charged. So how I actually charge the comb? Actually I try to comb my hairs, and और जब comb मेरे hairs पे rub हुआ, it tends to get charged. So that is how I charge it. So once it is charged, we can see that it attracts the piece of paper towards itself, and it also attracts the stream of water towards itself. So this is the study of this kind of attraction by the charged body. It is called electrostatics. It is called by the name of electrostatics, and we are going to discuss this electrostatics in this chapter and the next chapter which will be following this. So how actually this came into picture, the electrostatics. So a Greek scientist who goes by the name of Thames of Miletus, actually यही इसका नाम है. I even tried checking on the Google. So this is only is its real name. I know it is weird, but that is how it is. So उसने क्या observe किया कि when we take a glass rod and we try to rub it with the silk cloth, and we take another glass rod, we try to rub it with the silk cloth, and when we bring these two glass rods together, they tend to repel each other. So at that time he wasn't knowing anything about the charges, the polarity. He was not knowing about the positive. He was not knowing about the negative charges. He was knowing only one thing, that when a glass rod it is rubbed with a silk cloth, and a similar glass rod it is again rubbed with a silk cloth, and when these two are brought together, they tend to attract each other. And he extended his experiment to the plastic rod, and he had a similar observation, that when a plastic rod it is rubbed with the silk cloth, and a similar plastic rod it is rubbed with the silk cloth, and both of this plastic rod they are brought together, they again tend to repel each other. पर ये बिल्कुल उल्टा हो गया जब उसने उसी सिल्क क्लॉथ से प्लास्टिक रॉड को रब किया एंड उसी सिल्क क्लॉथ से ग्लास रॉड को रब किया. And when he bought this glass rod and plastic rod near to each other, he was surprised to see that they tend to attract each other. Sorry for this. That is, they tend to attract each other. They attract each other. So at that time, he wasn't knowing anything about the charges. It was just his observation. Like if you will rub a glass rod, it will tend a glass rod, and if you have a similar glass rod rubbed with the silk cloth, they will repel each other. And same is for the plastic rod. But when plastic rod and glass rod are brought into contact with each other, they tend to attract each other. Glass rod, when it is rubbed with the silk cloth, and the other glass rod when it is rubbed with the silk cloth, and when these two glass rods they are brought near to each other, they tend to repel each other. तो ऐसा क्या होता है जो उनमें ग्लास रॉड्स में रिपल्शन पैदा कर देता है? We will try to understand that. So like this is if our glass rod and this is our silk cloth. So the glass rod tends to get a positive charge, and silk cloth it tends to get a negative charge. So for this, we have to remember this concept that within a body, atoms are present, and atom has a nucleus which has neutrons and a proton, and it is there is an electron which keep on revolving around the nucleus. So if any given body, it has n1 number of electrons which are negatively charged and n2 number of protons which is positively charged. So generally in our day-to-day life, if we see most of the bodies, they are electrically neutral, which means the number of electrons, it will be exactly equal to the number of protons. But when we are rubbing a glass rod with a silk cloth, the electrons in the outermost shell, they get excited, and they have tendency to move outside from this orbit. So the electrons which are present within the glass rod, they have higher probability of moving out, whereas the electrons which are present in silk cloth, they have a very lower probability of moving out. So that is why the electrons from glass rod, they moves out towards the silk cloth. Thereby, the glass rod, it becomes electron deficient, and the silk cloth, it has excess of electron. Thereby, it develops a negative charge, whereas it has a positive charge. So the other thing which we can understand from here is that if the transfer, when the transfer just start to take place, when we are just rubbing the body, जब हम just body को rub करना start करते हैं glass rod को silk cloth से, it will start with the movement of one electron, then it will go on to 2 electrons, then it will go on to 3 electrons, then it will go to 4 electrons, and so on up, it will go up to 9 electrons. So it means the number of electrons which are transferred, it can only be an integer number. So if this is the charge onto each electron, the net charge transferred to body which is negative, it will be n times the charge on one electron. So अगर मैं थोड़ा सा और इसे थोड़ा दूसरे शब्दों में समझाऊं, तो जब इलेक्ट्रॉन्स ट्रांसफर करते हैं तो दे कैन ओनली ट्रांसफर ऐसे इंटीजर मल्टीपल्स, या तो एक इलेक्ट्रॉन जाएगा या 2 या 3. ऐसा नहीं होगा कभी भी 2.5 इलेक्ट्रॉन चले गए, 2.25 इलेक्ट्रॉन चले गए, और हर इलेक्ट्रॉन के ऊपर एक डेफिनेटिव चार्ज है. इट इज जनरली 1.6 into 10 raised to power -19 कूलम. तो एक इलेक्ट्रॉन जाएगा तो इतना चार्ज ट्रांसफर होगा, 2 जाएंगे तो इट विल बी 2 into this, और अगर 3 जाएंगे तो इट विल बी 3 into this. So the amount of charge transfer, it will be integer multiple of charge on one electron, because electron they are mainly the charge carriers. तो जो हमारा सिल्क है, it will develop a negative charge as a integer multiple of charge on one electron, and जो हमारा ग्लास रॉड है it will be losing electron. It will develop an equivalent positive charge which will again be an integer multiple of charge on one uh, charge on one electron or one proton, because proton and electron, they have exactly similar charges. So they both of them have exactly similar charges. So other thing is, like I think you all know this, that the like charges, they always repel each other. It may be positive and positive, it may be negative and negative, or it may be positive and negative. They always tend to repel each other. But the unlike charges, the positive with the negative or the negative with positive, they tends to attract each other. And this polarity, it was understood by Benjamin Franklin. So he said that body which will be in excess of electron, we will call it negative, and body which will be deficient of electron, we will call it positive. So there is a very simple experiment which is related to this, and even though it is a very basic instrument, but it is available around the world. So it actually shows how the charge it transfers from one body to another body. It has a insulated box, like you can see. This is the box which has glass windows, so we can see through it. And it has metal rod. It is generally of brass, which is connected to glass leaves. So why we choose the glass leaves? Because these are the gold leaves. So why we actually choose gold leaves? Because we know gold is a kind of material which is very malleable and ductile. So it can be drawn into thin sheets. And why we want thin sheets? So we can see the deflection. So even with a minute of charge, we will understand this from where deflection will come. But when we have a thin gold leaves, the deflection within the gold leaves, it will be very much visible to our naked eyes. It will be very much visible to our naked eyes. So what we are doing is, initially there will be no observations. For example, if this is our gold leaf electroscope, initially there will be no observation. Suppose if we positively charge our glass electrode, हमने अपनी glass electrode को positively charge कर दिया by rubbing it with the silk cloth. Now it has all the positive charge on it. अगर मैं अपनी positively charged glass rod को इसके contact में लेके आऊंगा, तो I know initially metal rod, it is a neutral because it has equal number of protons and it has equal number of electrons. So the number of protons and electron will be equal. But जब contact में एक glass rod आ गई जो positively charged है, तो जो electrons हैं within this metallic rod, they have tendency to move towards the negative charge because the opposite charge it attracts. So in the top region, it will be more of the negative charge because of attraction with the positive charge, and in bottom region, including the gold leaf, it will be positive charge. So both the gold leaves, they will have a positive charge, and as a result of which they will tend to repel each other. Or we will have a similar observation. अगर instead of bringing a positive charge, we bring a negative charge. अगर हम negative charge लेके आएंगे, तो initially it has no observation, यानी कोई deflection नहीं दिखेगा हमें gold leaf पे. पर जैसे ही हमने negative charge यहाँ लेके आए through an plastic rod, क्योंकि plastic rod हमने देखा ना, जब हम plastic rod को सिलिक के साथ रब करते हैं तो उस पर negative charge develop हो जाता. तो जब यहाँ पे नेगेटिव चार्ज होगा थ्रू द प्लास्टिक रॉड, तो जो मेटल पार्ट का पॉजिटिव चार्ज है it will tend to transfer towards the upper end, और जो हमारा लोअर एंड है it will develop more of a negative charge. तो both जो gold leaves हैं they will again have a negative charge, so they will tend to repel each other. So as I already discussed, that all the matters, it is made up of atoms and or molecules, or atoms में जो protons और electrons होते हैं, they only mainly contributes towards the charge. Or electrons, they are said to be main charge carriers. तो एक छोटा सा ये पॉइंट और है, forces that hold the molecule together, forces that hold atoms together in a solid, the adhesive forces of a glue, the forces associated with the surface tension, they all are basically electrical in nature, arising from the forces between the charged particle. तो ये जितनी भी forces के मैंने नाम लिए, they can all be categorized as a electrostatic charge, like as a electrostatic forces. They all come in the field of electrostatic forces. We will discuss in more detail about all this. We will be discussing all this separately, और इनके बारे में हम discuss आने वाले chapters में करेंगे. For time being, it is not that important, I will say. So now there are some basic properties of an electric charge, और एक बात याद रखिएगा कि there is one term called the point charge. So point charge is when the size of charge, it is very small, it is very minute in comparison to the distance between two charges. So we call the charge to be a point charge. So the other property of charge is that charges, they are additive in nature. Like अगर मान लीजिए मेरे पास एक glass rod है, I have one glass rod which have a positive charge on it, and I have another glass rod which again have a positive charge on it. So it is 3 coulomb and say it is 2 coulomb, and I am bringing them in contact with each other. Even though they will repel, but still I think the force will not be sufficient enough that we cannot bring them together. अगर हम थोड़ा सा push करेंगे, definitely they will come in contact. So now net charge on this two system, it will be 5 coulomb. So it is additive. So the charges, they are they can be added to each other. They can be added algebraically. तो और सेकेंड एग्जाम्पल है चार्ज, इट cannot be generated, there is only a transfer of charge. और ये हमने बड़े अच्छे से समझ लिया है. जब हमारे पास एक ग्लास रॉड है और जब हम उसे रब करते हैं सिल्क क्लॉथ के साथ, तो इलेक्ट्रॉन ट्रांसफर होते हैं. It start with 1 electron, it go to 2 electron, then it goes to 3 electron. तो इलेक्ट्रॉन ट्रांसफर हो रहे हैं which are integer multiple, which are integer multiple. तो जितने इलेक्ट्रॉन इससे ट्रांसफर हो रहे हैं, जितना इस पे नेगेटिव चार्ज बन रहा है, उतना ही इस पे पॉजिटिव चार्ज बनेगा. तो अगर हम इस सारे सिस्टम को देखें तो कोई बाहर से एक्स्ट्रा चार्ज नहीं जनरेट हो रहा है. द चार्ज इज गेटिंग कंजर्व्ड विद इन द सिस्टम. It is only getting transferred from one body to the another body. So that is charge is conserved. Now this is a very important quality of charge. It is quantization of charge. As I already said that when charge is transferring in terms of electrons from one body to another body, it will be taking place as a integer multiple. Like अगर या तो एक इलेक्ट्रॉन जाएगा या 2 इलेक्ट्रॉन जाएंगे या 3 इलेक्ट्रॉन जाएंगे, और हर इलेक्ट्रॉन अपने साथ चार्ज कितना लेके जाएगा, इट विल बी 1.6 into 10 raised to power -19 कूलम. और जितना ही चार्ज किसी बॉडी के पास इलेक्ट्रॉन आने से आएगा, उतना ही दूसरी बॉडी के पास चार्ज इलेक्ट्रॉन जाने से जाएगा. तो नेट like what I am trying to say is जितना नेगेटिव इस पे आया उतना ही पॉजिटिव इस पे आएगा. And if we have to mathematically write the quantization of charge, so charge developed onto any body, it will be integer multiple of charge onto the electrons. So it will be like this. तो अब इसी में से बड़ा एक ब्यूटीफुल सा क्वेश्चन बन रहा है। अब हमने तो कह दिया भी एक इलेक्ट्रॉन चला गया तो इतना चार्ज बन गया, मान लीजिए एक बॉडी से दूसरी बॉडी तक एक इलेक्ट्रॉन चला गया, जस्ट वी स्टार्ट विद वन इलेक्ट्रॉन। तो अब इस पे क्या चार्ज आ जाएगा, इट विल बी इक्वलेंट टू चार्ज ऑन वन इलेक्ट्रॉन, सो इट विल बी 10 रेज टू पावर 1.6 इंटू 10 रेज टू पावर -19 कूलम, और ये नेगेटिव का होगा क्योंकि इसे इलेक्ट्रॉन मिला है, और इलेक्ट्रॉन दे आर ऑलवेज नेगेटिवली चार्ज, और इससे इलेक्ट्रॉन खोया है, तो ये दिस इज ग्लास रॉड, इससे इलेक्ट्रॉन खोया है, तो इस पे उतना ही चार्ज आएगा बट इट विल बी पॉजिटिव, अब एक बड़ा ही प्यारा सा क्वेश्चन इसमें से निकल के आता है कि हाउ मेनी इलेक्ट्रॉन डू वी नीड टू लूज इन ऑर्डर टू जनरेट ए चार्ज ऑफ 1 माइक्रोकूलम। तो एक अभी के लिए याद रखिएगा बात कि यूनिट ऑफ चार्ज इट इज कूलम, but it is a very bigger unit of charge. We will see why it is a very bigger unit of charge. So instead of coulomb, we are using microcoulomb. तो इसीलिए we want to build a charge of 1 microcoulomb onto a body. तो how many electrons we need to transfer? और फिर से वही बात मैं एक फिर से दोहराऊंगा कि अगर अगर 1 माइक्रोन का चार्ज, माइक्रोकूलम का चार्ज इस पे डेवलप करना है तो इस पे -1 माइक्रोन का चार्ज डेवलप होगा, क्योंकि अगर इसे हम ग्लास रॉड और अगेन सिल्क क्लॉथ का एग्जांपल ले लें तो जितने इलेक्ट्रॉन इसके पास जा रहे हैं उतने ही इसके पास से मिस हो रहे हैं। द ग्लास रॉड इज लूजिंग द इलेक्ट्रॉन्स वेयर एज दिस इज गेनिंग द इलेक्ट्रॉन, सो दैट इज व्हाई द नेगेटिव चार्ज इज बिल्डिंग ऑन सिल्क क्लॉथ वेयर एज द पॉजिटिव चार्ज इज बिल्डिंग ऑन टू द ग्लास रॉड। तो अब हमें एक सिंपल सी बात पता है, क्वांटाइजेशन ऑफ चार्ज, द चार्ज विच वी हैव टू बिल्ड ऑन टू ए बॉडी, इट इज इंटीजर मल्टीपल ऑफ चार्ज ऑन 1 इलेक्ट्रॉन और प्रोटॉन। तो वी वांट टू बिल्ड ए चार्ज ऑफ से 1 माइक्रो कूलम, तो वी नीड टू कैलकुलेट द n, and we already know a charge on 1 electron, so it is equivalent to this. So if I convert this into coulomb, so it will look something like this, and I have this, so I think now you can figure out that n, it can be easily calculated. It will be the number of electrons which need to be transferred, so I will try to calculate it. I might be doing some mistake in the calculation, but you please beg me pardon in case I do it. So roughly it comes out to be this. So एक just to develop a charge of -1 microcoulomb onto a silk cloth need to receive this much amount of electrons, और जो glass rod है it needs to lose this much amount of electron. You can see the magnitude of electrons which need to be lost by glass cloth and the magnitude of electron to be gained by silk cloth. अब इसी पे ही एक दूसरा बड़ा प्यारा सा सवाल है which can be important from board point of perspective. So it is saying that can we charge a body by 32 microcoulomb? और अब देखिए अगर हमें बॉडी को 32 माइक्रोकूलम चार्ज करना है तो बॉडी हैज टू लूज इलेक्ट्रॉन्स, और अगर हमें ये कंफर्म करना है कि कैन बॉडी हैव दिस मच अमाउंट ऑफ चार्ज, सो वी नीड टू कैलकुलेट n अगेन, एंड या यू राइटली गेस्ड, इफ n is integer, this much amount of charge is possible. Now this is in micron. और अगर n integer के बिना कुछ भी आता है then it is not possible to get that charge. तो मैं क्विकली से ये सॉल्व करूंगा. अगेन kindly beg me if I do any mistake in calculation. So it will be 10, it will go up, so it will be 10 raised to power -2 plus 19 divided by 1.6. So yeah, I think n is coming out to be integer. तो यहाँ पे पॉइंट नहीं होगा क्योंकि हमने 10 से ऊपर मल्टीप्लाई कर दिया है, so it will be 2 into 10 raised to power 17. So yes, so if one body loses this many amount of electron, it will develop a net positive charge of 32 microcoulomb. So yeah, this is possible. So there is another very important question. मेरा ये अप्रोच रहेगा कि I discuss as many as problems with you, because I feel that by discussing problems, your fundamentals they are becoming more and more clearer. And once we are done with this basic problems, even though they are very important from board point of perspective, surely we will switch to problems which are important from competitive point of view. So it is saying that if 10 raised to power 9 electrons move out of a body in every second, how much time is required to build a charge of minus 1 coulomb on other body, or to produce a charge of 1 coulomb on this body. तो एक सेकंड में 10 रेज टू पावर माइनस 9 इलेक्ट्रॉन्स पर सेकंड एक बॉडी लूज कर रहा है. अगेन वही फिर हम अपना एग्जांपल ले लेते हैं. इट मे बी ए ग्लास रॉड एंड ए सिल्क क्लॉथ. तो इस पे माइनस 1 कूलम डेवलप होगा बिकॉज इट इज गेनिंग इलेक्ट्रॉन, एंड इस पे प्लस 1 कूलम डेवलप होगा बिकॉज इट इज लूजिंग द इलेक्ट्रॉन्स. तो इफ 10 raised to power 9 electrons they are moving every second, और देखिए अगर 10 raised to power 10 raised to power 9 इलेक्ट्रॉन पर सेकेंड मूव जा रहे हैं, ग्लास रॉड इज लूजिंग इट, तो चार्ज कितना जा रहा है? सो इट विल बी 10 raised to power 9 इंटू इतने इलेक्ट्रॉन जा रहे हैं, और एक इलेक्ट्रॉन पे चार्ज है ये वाला 19 कूलम. सो दिस मच चार्ज इट इज बिल्डिंग एवरी सेकेंड. तो एक सेकेंड में हमारा चार्ज बन रहा 1.6 इंटू 10 raised to power माइनस 10 एक सेकेंड में, और हमें बिल्ड करना है 1 कूलम. ठीक है, तो हमें बिल्ड करना है 1 कूलम. एक सेकेंड में इतना जा रहा, और हमें बिल्ड करना है 1 कूलम. सो या वी विल टेक इट टू बी x. Now we can use unitary method also. So x into 1.6 into 10 raised to power minus 10 is equals to 1. So x it will be 1 by 1.6 into 10 raised to power. So yeah, so it will be 1 by 1.6 into, so it will go upside, it will be into this much. So it will be somewhere around this much seconds. This is another very important problem which discusses about the number of positive and negative charge which we intake while we drink one glass of water. So you will be surprised to see this, that how many charges we take each time we drink one simple or small glass of water. So as we know, density of water is 1. So the weight of glass, it will be exactly equivalent to volume. So it will be 250 gram. And we know that the molecular weight of water, it is 18 gram. And within this, it contains Avogadro number of atoms. So now if I know that in a molecular weight, it will be Avogadro number of atoms. So I want to calculate how many number of atoms will be in 250 gram. So again, I will use the unitary method. Like I will say in 1 gram, it will be 6.23 into 10 raised to power 23 divided by 18. Yeah, so I will be dividing this by this. So it will give me for 1 gram. And if I want to calculate for 250 gram, I will multiply this with 250 gram. So I will multiply this with 250 gram. So roughly it will be 1, and it will be 3. It will again be 1. And it will be 8, something around 83. I know it may not be exactly accurate, but it will be good enough to give you an approximate idea. So there will be this much amount of atom in 250 grams of water. Now for hydrogen, we know it has two H atoms, and each H atom it has one proton and one electron. So it will be two proton, two electron from this, and other is oxygen, which has eight electron and eight protons. So in total, I have 10 protons and I have 10 electrons within an hydrogen atom. So yeah, so I have this. So number of electrons which I take, it will be into 10, and it will be equal to number of protons which I take. So it will be roughly equivalent to this. So this is the amount of electron and proton which I take when I drink only 250 volume of 250 ml of the water. और इस वजह से हमें कुछ फील नहीं होता. रीजन है कि जितना हम नेगेटिव चार्ज लेते हैं बिकॉज ऑफ इलेक्ट्रॉन, उतना ही हम पॉजिटिव चार्ज ले लेते हैं. तो इन टोटलिटी इट रिमेन्स न्यूट्रल. So after this, we switch to another very beautiful law, which we call it as Coulomb's law. तो what Coulomb's law says, और ये काम किसके आता है, किस काम आता है हमारे, तो Coulomb law is generally used to calculate the forces which act between two charges. Like I have a charge this and I have charge this. I name this to be Q1 and I name this to be Q2. And if I say both they are positive charges, और अभी तक हमने यही पढ़ा है कि जो पॉजिटिव चार्जेस हैं they tend to repel each other. तो यहां से हमारी एक लाइन पास कर रही है which is passing through the center. If they are repelling each other, they will be exerting forces in this direction. And how we name this force, it will be force on 1 due to 2. So 1 मैंने वो लिखा है जिसपे फोर्स हमें कैलकुलेट करनी है, और दूसरी पोजीशन पे मैंने वो लिखा है जो फोर्स लगा रहा है. और सिमिलरली अगर मैं यहां फोर्स लिखूंगा, इट विल बी फोर्स on second due to 1. And we all know that force, it is a vector quantity. So they will be repelling each other. So Coulomb law says that forces which are exerted, it is equals to K times, K is a constant. We will discuss it in detail just in few moments. So it will be product of the charges which are being placed, and it will be inversely proportional to the distance between these two. तो अगर हम distance बढ़ाते जाएंगे तो by square it will keep on decreasing. और अगर हम चार्ज बढ़ाते जाएंगे तो जो हमारी फोर्स है, either it can be repulsion, अगर दोनों एक से चार्जेस हैं ना, and if they are same charges, it will be force of attraction. It will tend to increase अगर हम चार्जेस बढ़ाते जा रहे हैं. और अगर आप देखें तो ये थोड़ा देखने में हमें सिमिलर सा नहीं लग रहा वो ग्रेविटेशनल फोर्स के. ग्रेविटेशनल फोर्स का हमारा जो रिलेशन था, इट वाज समवट लाइक दिस, एंड दिस इट वाज ए ग्रेविटेशनल कांस्टेंट. तो इट वाज ए कांस्टेंट which was a universal constant, और हर जगह पे हम एक ही वैल्यू लेते हैं इसकी irrespective of the medium in which we are. पर जो हमारा K है, it depends on the permeability of the system. Like K, it will be equivalent to 1 by 4 pi epsilon naught. For time being हमें यही याद रखने की जरूरत है कि permeability for free space it is this much. और अगर हम इसे प्लग इन करके हमारा K का वैल्यू निकालें, इट विल कम आउट टू बी 9 into 10 raised to power 9 Newton meter square per Coulomb square. So it will be equivalent to this. Or there are certain similarities and there are certain differences between the gravitational force जो मैंने यहाँ लिख रखा है and the electrostatic force. We call this to be electrostatic force. We will also discuss that how Coulomb was able to drive this formula. Just in a short while we will discuss that also. तो अभी के लिए आप इतना याद रखिए कि जो इलेक्ट्रोस्टैटिक फोर्स दो चार्जेस के बीच में होगा इट विल बी इक्विवेलेंट टू k टाइम्स द मैग्नीट्यूड ऑफ दोस चार्जेस डिवाइडेड बाय द डिस्टेंस बिटवीन देम. ठीक है. और अगर हम इसे थोड़ा सा वेक्टर नोटेशन में लिखना चाहें, if we are interested in writing it in vector notation, it will be like this. So electrostatic force, it will be equals to k, it is a constant, into q1 by q2 divided by, suppose if I am calculating this force between q1 and q2, it will be divided by r21 magnitude of this vector square into r21 the unit vector. So unit vector, it will tell us the direction. So this unit vector, it will tell us the direction. So if I am writing it like this, it means I am calculating a force on second due to 1. और अगर मुझे vice versa calculate करना हो, अगर I have to calculate force on 1 due to 2, then it will be equivalent to this q1 by q2 divided by r12 square into r12 the unit vector. So now if I see, like we all know that the r21 vector, it will be negative of r12 vector. So it means if I plug my r21 into this in terms of r12, it will be a negative r12. So it means थोड़ा मैसी हो गया. I know, I understand. थोड़ा हम दोबारा से डिस्कस करते हैं इस चीज को. It is also a kind of important question. How we can write this Coulomb's law in vector form. It is also very important. But in vector form, it is written like this only. और जब हम आगे problems करेंगे, we will discuss it in more detail. So in vector form, it is written like this. Now we know unit vector. How we calculate unit vector? It is the vector divided by its magnitude. तो अगर हम ये वाली वेक्टर डिवाइडेड बाय मैग्नीट्यूड प्लग इन कर देंगे तो यहाँ पे भी वेक्टर आ जाएगा एंड डाउन साइड इट विल बी क्यूब. वी विल डिस्कस दिस. आई नो इट इज गेटिंग बिट मेसियर हियर, सो वी विल श्योरली डिस्कस दिस. बट बिफोर दैट वी विल डिस्कस द सिमिलैरिटीज which are between the gravitational force and the differences which are between the gravitational force and the electrostatic force. So maybe so the similarities are that both the forces, either the gravitational force or the electrostatic force, they are inversely proportional to square of the distance, as we can see in this too. And both the forces they act along the line which join the center of the body. In case of electrostatic force, it will be charge. In case of gravitational force, it will be mass. And there are numerous differences between these two. First one is, now our gravitational force, it is always attractive. Our gravitational force, it is always attractive. ये आपने थोड़ा ये तो you can imagine like if we let free any body from our hand, it will always go downside because it has a gravitational pull acting on it. And so we say the gravitational force is always attractive. But our electrostatic force, It can either be attractive or it can also be repulsive. It depends upon the nature of charges. अगर दो चार्ज एक से हैं तो it will be repulsive, पर अगर दो चार्ज opposite हैं तो it will be attractive. The other difference is that the gravitational force, it does not depends on the medium. Like अगर हम देखें तो हमने gravitational force को कैसे लिखा था, तो we wrote it as G, which is a universal constant. It will be mass of one body, mass of second body divided by distance between two. So G, it does not depend on medium. It has only one value, which is equivalent to this. Whereas our K, it depends on the medium. अभी के लिए हमने सिर्फ फ्री स्पेस के लिए देखा है और इसकी जो वैल्यू है इट इज 9 into 10⁻⁹ न्यूटन मीटर स्क्वायर पर कूलम स्क्वायर. और अदर इज कि Fg इट इज वेरी स्मॉल. ये हम आगे न्यूमेरिकल्स में भी देखेंगे. Fg it is very small in comparison to Fe. एंड इसका रीजन एक तो साफ है कि जो कांस्टेंट है फॉर इलेक्ट्रोस्टैटिक फोर्स इट इज रियली हाई. ये देखिए यहाँ पे 10⁻⁹ है, whereas G it is only 10⁻⁻11. So these are some of the differences between these two. And अभी हमारा वेक्टर फॉर्म वाला रह गया है. We will discuss that shortly. उससे पहले एक न्यूमेरिकल कर लेते हैं. अच्छा, एक बड़ा अच्छा मैंने आपसे डिस्कस किया था. आई वॉज अबाउट टू डिस्कस इट विद यू. अच्छा, तो अब पता नहीं आपको लगे या ना लगे, बट इट वॉज लाइक हाउ कूलम ड्राफ्टेड दिस लॉ. ही सेड दैट Fe it will be equivalent to K times Q1 Q2 by R square. तो actually how Coulomb started was he took 4 bodies. जैसे उसने 4 बॉडी ली, जैसे एक को मैंने A कहा और दूसरे को B कहा. देन आई सेड आई हैव C, देन आई हैव D. तो there is certain charge on this Q and there is certain other charge on D Q dash. I bring this two in contact. और अगर साइज और शेप और मटेरियल सेम है तो दिस चार्ज इट विल बी इक्वली डिस्ट्रीब्यूटेड अमंग A एंड C. तो A और जैसी मैं इन दोनों को कांटेक्ट में लेके आया तो A पे जो चार्ज है इट विल आल्सो बी Q/2 और C पे जो चार्ज है इट विल आल्सो बी Q/2. सिमिलरली B पे जो चार्ज है इट विल बी Q'/2 और D पे जो चार्ज है इट विल अगेन बी Q'/2. तो अगर साइज, शेप और मटेरियल सेम है, चार्ज इट गेट इक्वली डिस्ट्रीब्यूटेड. सो अब कूलम ने क्या किया, इनिशियली ही केप्ट A एंड C एट सर्टेन डिस्टेंस. तो उसने A को और C को एक सर्टेन डिस्टेंस पे रखा. सॉरी, A और C को एक सर्टेन डिस्टेंस पे रखा. So he saw some force and he measured these forces with torsional balance. तो torsional balance एक अपने आप में एक बड़ा important और interesting topic है. We will not go into this. For time being we will stick that he measured force somehow. तो उसने forces measure की. अब उसने क्या किया, A और C में distance almost double कर दिया. तो जैसे ही उसने distance double किया उसने देखा कि जो फोर्सेस हैं वो 1/4 टाइम्स हो गई. अब he was very much interested by this and he again doubled the distance. So again he saw that the forces, if we compare this case with this, the forces they became 1/16 times. So he came to a conclusion that electrostatic force it obeys the square of distance rule when it comes to electrostatic forces. और अब सेम चीज उसने क्या किया, उसने जैसे अब चार्जेस को वो डिवाइड करता गया. हाउ वी कैन डिवाइड ए चार्ज. अगर मुझे चार्ज को डिवाइड करना हो तो मैं एक और बॉडी सेम साइज और सेम मटेरियल की आई कैन ब्रिंग इट टू इन कॉन्टेक्ट विद ए एंड डी. सपोज आई नेम इट एज ई एंड एफ, और जैसी मैं इसे कॉन्टेक्ट में लेके आया, द चार्ज जो उस पर पहले था इट आल्सो गेट इक्वली डिवाइडेड. इट बिकम्स क्यू बाय 4, it becomes q by 4, and it becomes q by 4. So it get equally divided. तो now I have range of charges. तो मैं जैसे पहले कॉलम ने क्या किया कि ए और सी को कांटेक्ट में रख के देख लिया. अब ए पे चार्ज क्या है q by 4 और सी पे चार्ज क्या है q by 2. तो उसने इन दोनों को कांटेक्ट में नहीं, डिस्टेंस पे रख के देखा सर्टेन. तो उसने देखा कि जो फोर्सेस डेवलप हो रही हैं, क्योंकि अब चार्जेस ए तो एटलीस्ट हाफ हो गया है, तो हिज फोर्सेस आल्सो दे बिकेम हाफ. और फिर उसने क्या किया, उसने सी को भी हाफ कर दिया. सी को हाफ कैसे किया कि सी की जगह पे उसने मान लीजिए बी रख दिया. तो उसने बी रख दिया. अब जो चार्ज क्यू बाय 2 था अब वो क्यू बाय 4 हो गया. तो पहले के मुकाबले चार्ज भी आधा हो गया. So he again saw that forces they became half of what they were initially. So this is how he built an observation that if you are reducing the charge, the electrostatic forces they will be linearly reduced. But if you are increasing the distance between two charges, the electrostatic forces they will reduce by the square of the distance between these two. अब इसी पे एक छोटा सा न्यूमेरिकल कर लेते हैं हम. आप तब तक थोड़ा स्टेटमेंट पढ़िए. आई विल मीनवाइल आई विल रब दिस. तो ही सेज ए चार्ज क्यू इज डिवाइडेड इनटू टू पार्ट्स एंड केप्ट एट ए फिक्स डिस्टेंस अपार्ट. अब दो एक चार्ज क्यू है हमारे पास, हमने दो में स्प्लिट कर दिया. अब किस किस में कैसे कैसे किया है, ही नेवर से इसने ये नहीं कहा कि इट इज डिवाइडेड और स्प्लिटेड इनटू इक्वल पार्ट्स. he just said it is splitted. It can be equal, it can be 1 by 3, other can be 2 by 3. We doesn't know about it, but it is splitted. So एक हमारे पास Q charge है and we are splitting it into two parts. So initially we have Q. तो we are splitting it into two. तो suppose एक मेरा जो चार्ज है it is X, I can take it coulomb. और एक and other it can be Q minus X coulomb. They should be divided into what fraction such that electrostatic force is maximum. तो पहले तो हम देखें भी electrostatic force है क्या इन दोनों में. तो if we try to calculate the electrostatic force, it will be K times first charge into second charge, or distance fix है, we take it to be r square. Now we have to maximize this. We have to maximize the electrostatic force in terms of the charge. So we have to maximize it in terms of x. So you know this. If I have to maximize a function with respect to certain other function, I have to take derivative and place it equivalent to 0 to find a point at which the value is maximum. तो मैंने वही किया. I took derivative and equated it equals to 0. So if I take derivative of this, it will be K times xq minus kx square by r square. So I have to place it equals to 0. So yeah, now I have already taken the derivative, so I need not to write derivative again. No, sorry, I have not taken the derivative, so I need to write the derivative. So it will be equivalent to and now I am taking derivative. It will be kq. So it will be x derivative of x, it will be 1 minus 2kx divided by r square, and I have to make it equals to 0. So this it will go 0. So I will like adjust this terms. मैंने जब adjust किया तो it comes out equivalent to this. Now if I calculate for my x, this will cancel out. My x, it will be q by 2. So it means if I want the electrostatic force to be maximum between two charges, I need to make them exactly half, and at whatever distance I keep them, in terms of charge, in terms of division of charge, it will be maximum when they are splitted into two equal halves. So this is a very another important question. So it can be asked in MCQs. So I will try to solve only one part of this, because if I will try to solve all the parts, तो I think वो बहुत time लगेगा. You may try to solve other part by your own. तो इसमें क्या है? They are saying that we compare the strength of gravitational and electrostatic force by determining the ratio of their magnitude. तो हमें ratio निकालना है. We have to calculate ratio of Fe to Fg, where Fe is electrostatic force and Fg is gravitational force. We know Fe, it will be equivalent to K times Q1, Q2 divided by R square, and our Fg, it will be equivalent to G times M1, M2 by R square. So now if I take a ratio of this two, K Q1 by K2 divided by G M1 by M2, मैंने इनका रेशियो ले लिया, तो R square cancel हो जाएगा. I am only left with this. So I already know value for K. It is 9 into 10 raised to power 9. And G, it is 6.67 into 10 raised to power minus 11 into, so I am only left with Q1, Q2 divided by M1, M2. So if I try solving this, so it will be somewhat like 1.3 into 10 raised to power 20 into, like, I am solving for this. So this is for two protons. So now I need to consider this. So charge on two protons, it will be 1.6 into 10 raised to power minus 19. Charge, it is same. On proton, it is exactly equivalent to what is there on the electron. So 1.6 into 10 raised to power minus 19 divided by the mass. तो अगर आप देखेंगे तो प्रोटॉन का मास है जो इट इज 1000 टाइम्स, इट इज 10,000 टाइम्स लेसर देन मास ऑफ द इलेक्ट्रॉन. इवन दो प्रोटॉन का मास कम है, but still I think it is in the nucleus. It has lesser tendency to migrate when two bodies are rubbed against each other, whereas electron, even though it is heavier, but it is loosely bounded to the nucleus, and when two bodies are rubbed together, it shows tendency to migrate. और इसीलिए हम कहते हैं भी जो इलेक्ट्रॉन्स ही हमारे, they are only the charge carrier. So it will be square of this. So I am writing it to be square of this. So this is 19. So I will try to rub the top portion. So I'm just trying to solve only one, because it will give you, sorry, it will give you an estimation of how, that what is the relation between electrostatic and the gravitational force. Which one is bigger, and if someone is bigger, by how much magnitude it is bigger. So crudely, I am crossing this 1.6 with 1.67, and as I have taken square of this, I know there is another 1.67, so I am also cutting it with that. So it means I have 1.3, I have nothing left out of this four terms. I have 10 raised to power 20 minus 19 minus 19 plus 54. So it will be 1.3 times 10 raised to power 20 minus 38. It will be minus, so this will be minus 38. So 20 minus 38, it will be minus 18. And we have plus 54. So we need to subtract. So it will 40, it will be 36. So this is the ratio of electrostatic force to the gravitational force. So you can imagine the magnitude by which a electrostatic force, it is larger than a gravitational force. So maybe that is why we not even experiences the gravitational force, but electrostatic force, it is always experienced. Like we also saw it in case of the paper pieces. So it was quite anomalous, like it was visible to naked eyes. So this is what we can conclude from this. So like similarly, you can try doing this. They are from your NCERT book only. So for an electron and a proton, so you can also estimate the acceleration by directly taking force is equals to mass into acceleration. You know the mass, you can calculate the force, and you can calculate the acceleration. So I will just switch to another problem which is also very interesting. So what it says that a charged metallic sphere A is suspended by a nylon thread. Another charged metallic sphere B held by an insulating handle is brought close to A such that the distance between their center is 10 centimeter. So distance between them is 10 centimeter. I think it is not visible. The resulting repulsion of A is noted by shining a beam of light and measuring the deflection of its shadow on the screen. So we just notice the reflection in A when we are bringing this two together. We don't know the exact amount of charge, but we know that they have the same charge. So that is why it will be repulsion only. So now the sphere A and B are touched by uncharged sphere C and D respectively as shown in figure. So now these two spheres, they are touched with sphere A and C. Again, this is again touched by a sphere. Yeah, this is also again touched by a sphere. C and D then are removed. तो एक बार टच करने के बाद हमने वो रिमूव कर दिए. And then B, it is again brought closer to A to a distance of 5 centimeter between the center. What is the expected repulsion of A on the basis of Coulomb's law? तो देखिए पहले हमारे पास जो A था, we assume that it has a charge Q, and similarly we can assume that B, it has a charge Q dash. So now when they are touched with another sphere and the sphere are taken back, तो just एक बार टच करवा के हम वापस ले गए, तो it has a charge Q by 2 A, this is A, और सेम यही चार्ज C और D पे भी डेवलप हुआ होगा. C पे Q by 2 और D पे Q dash by 2. So it will be same. तो अब चार्ज चाहे हाफ हो गया, बट व्हाट वी डिड वाज वी आल्सो रिड्यूस द डिस्टेंस बाय हाफ. तो पहले अगर इन दोनों में डिस्टेंस 10 सेंटीमीटर था, तो नाउ अब हमने डिस्टेंस क्या कर दिया, अब हमने जस्ट 5 सेंटीमीटर कर दिया. तो दिस इज व्हाट द प्रॉब्लम इट सेज. तो वी विल स्टार्ट डूइंग बाय दिस पार्ट, और यहां हम पहला वाला पार्ट कर देते हैं. तो इलेक्ट्रोस्टैटिक फोर्स इट विल बी K टाइम्स, अब चार्ज है Q एंड Q डैश डिवाइडेड बाय 10 स्क्वायर. ये फर्स्ट वाला केस था. नाउ सेकेंड टाइम K तो वही कांस्टेंट रहेगा बिकॉज द मीडियम इज सेम. but charge it get halved. It become q by 2, and another charge it also become q dash by 2, and distance it get halved. So it get halved by, so let's do it like this. We will not keep it as 10. Instead we will keep it as x. So it will be x square. ठीक है, बात तो एक ही है ना, वो इंस्टेड ऑफ टेकिंग ए वैल्यू आई एम टेकिंग इट टर्म्स ऑफ ए वेरिएबल. तो अगर ये x है तो नीचे वाला मेरा डिस्टेंस इट विल कम आउट टू बी x by 2 the whole square. So I will use the space. So I will use this space. So now from this, from the second part, when जब मैंने स्फीयर्स को टच कर दिया, उसके बाद मैंने साइड कर दिया और डिस्टेंस हाफ कर दिया, तो उस टाइम पे मेरी जो इलेक्ट्रोस्टैटिक फोर्स है इट विल बी इक्विवेलेंट टू Q into Q dash by 4 divided by X by 4. तो I already took the square. तो अगर मैं देखूं तो ये जो मेरी फोर्स है it is exactly equivalent to my first case. तो इसे क्या हमने कंक्लूड किया कि इवन दो हमने चार्ज ए और बी पे स्प्लिट करके हाफ कर दिया उनके साथ दूसरे स्पीयर्स को टच करके और डिस्टेंस हाफ कर दिया, पर जो इलेक्ट्रोस्टैटिक फोर्स है इट रिमेन्स सेम. So this is a very interesting problem and it is also very important from the board exam point of view. So I hope you understand this. So now we have a last topic. It is also very interesting one. So it is on the forces between the multiple charges. So here we use a principle of superposition. So principle of superposition says that force on any charge due to a number of other charges is the vector sum of all the forces on that charges due to other charges taken one at a time. So I will try to explain this in simple words. The individual forces are unaffected due to presence of the other charges. तो देखिए, अगर मान लीजिए मेरे पास एक Q1 चार्ज है and I have a Q2 charge. So if they, like I suppose they are equal charges, so they will exert some force. Sorry, they are similar charges. By similar means कि उन पे जो polarity है वो same है. तो अगर polarity same है तो there will act a force जो हमें कूलम ने बताया, and this force it will act along the line joining the center of these two masses. तो force on first charge it will be F12. And force on this two charge it will be F21. So it will be acting in this direction and it will be acting in this direction. और अगर हम एक तीसरा charge introduce कर दें, I call it Q3. So it will also exert certain force on Q1 also and Q2 also. Q2 also and Q1 also. And this force it will again act in the line joining their centers. It can also be calculated by Coulomb's law. It will also act in this line, in the line which is joining the center of their masses. And this force, because of 3, it will be F13. And in this direction, it will be F31. And similarly, there will be force of repulsion or force of attraction between these two. It may be like this. If they are similar charges, means they have a similar polarity. So according to principle of superposition, the net force acting on a charge, it will be vector sum of the force exerted onto it by the other charges. तो मैं अगर इसे सिंपल टर्म्स में लिखूं कि अगर जो नेट फोर्स 1 पे लग रही है, अगर मुझे वो कैलकुलेट करनी है, इट विल बी vector sum on vector sum of force applied on 1 by 2 plus force applied on 1 by 3. So it will be a vector sum of this two. It will be a vector sum of this two. और इस पे बड़े इंटरेस्टिंग न्यूमेरिकल्स हैं ये, थोड़ा सा, हाँ, इससे मुझे याद है कि वी आर स्टिल टू डू we are still to derive the Coulomb's law, or we are still to write the Coulomb's law in the vector form. Surely we will do that. So this is what our principle of superposition says. It will be much more clear to you when we will do some more numericals or some problems related to this. I think then it will become much more clearer to you. और इससे फर्क नहीं पड़ता कितनी भी चार्जेस हो, वी कैन टेक इवन द एन नंबर ऑफ चार्जेस, बट स्टिल वी कैन अप्लाई प्रिंसिपल ऑफ सुपरपोजिशन. आप आगे देखेंगे इट इज वेरी इंटरेस्टिंग काइंड ऑफ ए प्रिंसिपल, और जो बड़ा ही हेल्पफुल है. अगर मान लीजिए मेरे पास एक Q1 चार्ज है और इसके अगल बगल में आई हैव एन नंबर ऑफ चार्जेस. सो दिस इज Q1, दिस इज 2, this is 3, this is 4. I am not writing Q because of time constraint, so you can understand these are the charges. I am just numbering them. So force on charge 1 due to 2, it will be equivalent to K charge on 1, charge on 2 divided by distance between 1 and 2. So it will be magnitude of this, and it will be the position vector 1, 2. Similarly, अगर मैं लिखूं force on 1 due to 3, it will be K times charge on 1, charge or 3 into distance between these two into this. Now, if I want to generalize this, if I want to calculate the force on mass 1 due to charge n, it will be equivalent to K times Q1 Qn R1n whole square into unit vector in direction of 1 to n. Now my net force, or if I say F1, it will be vector sum of all this. So अगर मैं थोड़ा सा इसे एक शॉर्ट हैंड नोटेशन में लिखना चाहूं, आई नो K is constant and Q1 is constant. So I take them out. Now I have summation because all this they are in addition. So I have a summation. So K and Q1 they are outside. So I have Qi R1I into R cap 1I, whereas our I, it is varying from 2 to n. So this will be the net force onto my charge 1. So this is what principle of superposition. एक problem करते हैं which is related to principle of superposition. So it says that there are 3 charges which are placed on the vertices of an equilateral triangle, and side of equilateral triangle is x. What is the force on a charge Q which is placed at the centroid of the triangle? So we have to calculate the force on this. So all are similar charges, the polarity is same. So it means the charges, they will be repelling each other. So we have to calculate the force on Q. So now if we see the force on Q, so we will see one by one what will be the force on Q due to each charge. Suppose if I see because of charge which is placed at A, the Q1 charge. So I will try to redraw this. Beg me for my drawing. So this is the charge Q. So I have Q1 here. So Q. So Q, it is also written, it has the same sign as Q. So we know that it will be force of repulsion. So it will be force 1. And similarly, our Q2, it is also having same polarity as our Q, the mass which is placed on the centroid. So again, it will be repulsive. So this will be F2. And similarly for F3. So this will be how the forces they will be acting on big Q because of Q1, Q2 and Q3. So I think it is a very interesting but very simple problem. Now what we are interested in, what we are keen in is we are interested in finding out this distance or this distance. We are interested in finding AD. We are interested in finding, sorry, it is AO because it is the distance between vertex A to the centroid. So we are interested in finding BO. We are interested in finding CO. So if we have to find any of this, we need to find AD. We need to find AD. And once we have AD, we know that AO equal to BO is equals to CO, and it is equals to 2 by 3 of AD. So it is a property of a equilateral triangle. So it comes out from the symmetry. So the centroid, it is always placed at a distance of 2 by 3 of the distance of a perpendicular. 2 by 3, तो जो हमारा सेंट्रॉइड है ना इक्विलेटरल ट्रायंगल का, वो 2 by 3 डिस्टेंस पे प्रेजेंट होता है. 2 by 3 ऑफ व्हाट? 2 by 3 ऑफ द परपेंडिकुलर टॉप वाले वर्टेक्स से, एंड फ्रॉम बेस इट विल बी 1 by 3. सो वी नो दिस. तो ये हर साइड वाले के लिए होगा. इट विल बी सेम फॉर दिस, it will be same for this, it will be same for this. So that is why I wrote my AO, it will be equal to BO, it will be equal to CO, and it will be 2 by 3 of AD. So now we are interested in calculating our AD. So now if we take cos of 30, we know this, this particular angle is 30 because it is splitting it halfway, and this angle is 60. So cos of 60, it will be adjacent by hypotenuse. So adjacent, it will be AD, and hypotenuse, it will be L. So cos 30, it will be root 3 by 2, and AD, it will be root 3 by 2L. So our AO equal to BO equal to CO, it will be equivalent to root 3 by 2 into 2 by 3 L. So we already know L. So it means our AO, BO and CO, it will come equal to L by root 3. So it will come out equivalent to A by root 3. So I will rub this. Oops, I wrongly rubbed something which was required. So it's okay, I will write it again. So our AO, BO and CO, they will be equivalent to L by root 3. L by root 3. So we know this. So now if we calculate the forces, so firstly we will calculate F2. It will be equivalent to K times Q1 capital Q by distance. So I am calculating F2 is this force. So this distance, it will be BO, and BO, it is L by root 3 the whole square. So it will come out to be 3K Q1Q by L square. Now if you see the F3, it will also be similar because the charges, they are same, and the distance, it is also same. And so will be our F1. F1 will also be equivalent to F3, which will be also equivalent to F2. So now we know F1. So I will just write it down here because I may require to erase this part. F1 equal to F2 equals to F3, which will be equivalent to K Q. I can write it Q because Q1, Q2 and Q3, they are given equivalent to Q divided by L square, and we also have 3 here. So I know this. So now I'm at a point where I know O, I know I know F2, I know F3, and I know they are equal, and I know F1. So I need to calculate the net force onto a charge which is placed at Q. So if I see if this angle is 30 because this is equally separated by a perpendicular. So this is also 30. So this is an equilateral triangle. So 30, 30, 60. So this angle, it will be 120. And so this angle, the angle between these two forces, it will also be 120 degrees Celsius. So now if I have to calculate the net resultant, and I can take all these forces equal to F because they are equal. So if I want to calculate the net resultant, so it will be F square plus 2FF into cos of 120 degree. So it will be 2F square. Yeah, for time being. Now if I convert this cos into like I write it as cos 90 plus 30, I know in second quadrant, like I write after school to college, in my second quadrant my cos is negative, so it will get converted into sine, so it will be sine 30 degree. So and it will also become negative. So we know sine 30, it is, so it will be minus 2 F square by 2. So 2 get cancelled out. So I am only left with F square and under root, so which is equivalent to F. And our F1, it is also equivalent to F. Now where this force, it will exactly be acting. It will be exactly acting in the midway, like in this way. So when two forces, they are equal in magnitude, their resultant, it exactly lies within the center. So this is where my F is actually acting. Now if you see, our F is equals to F1 and they are exactly acting on a same line but in the opposite direction. So अगर ऐसा हो, तो what is the net force? So the net force, it will be 0. So what it means is that for an equilateral triangle, if I am placing it if I am placing a charge onto its centroid and I have placed equal charges on its vertices, the net force onto a charge placed onto the centroid, it will be 0. So like there can be so many questions which can be made out of this. Like instead of placing it on centroid, it can be placed at certain other distance, but the concept it will remain same. So you have to use this. Like you have to use principle of superposition of forces to calculate the net resultant force. And there may be so many other questions, like they may change the figure instead of the triangle, they may give you a square or they can give you a rectangle. But if you know the basic concepts, I think you will be easily able to solve this. So this is another important problem. I want you to solve this, or else we will surely discuss it in the next class. So it says that consider the charge Q, Q and Q minus Q placed at the vertices of an equilateral triangle. So these are the charges. This time they have made it to be minus Q, and all these charges, they are placed on the vertices. So now what we have to do is we have to calculate the force on each charge. So we have to calculate the force on each charge. So we will be separately taking this Q3, we will be separately taking, sorry for this, we will be separately taking this Q1, we will be separately taking Q2. And see, this is how the forces they will be acting. You just need to calculate F31. This will be force on 3 due to 1. Similarly, this F32, it will be force on 3 due to 2. And similarly, if we have to calculate the net resultant force, it will be the vector sum of these two forces. So it will be acting on this line. And similarly for this, the forces acting on the charge Q1, which is placed at A. So this time it will be an attractive force because this is negative, and similarly this is negative. This is positive. So it will be an attractive force, and these two, they are the similar charges. So they will be repulsive in nature. You try solving this, or else we will surely do it in the next class. So with this, I will ask you I will ask you for your feedback for sure.